Hey everybody, it's Miss Berry. Just doing a quick video here to show you how you can solve a system of equations with three equations and three variables using your graphing calculator that you're required to have for this class. So let me open up my iPad and show you the problem before we get started. All right, so here's the problem. The first equation is 5x plus 3y plus z equals negative 30, and then x minus 3y plus 2z equals 12, and then 14x minus 2y plus 3z equals negative 52. Now, for this method to work that I'm about to show you, you need to have all of these equations lined up so that the variables are matching up. You see how all of my x's come first, then my y's, then my z's, and then I have my constants over here on the right-hand side of the equal sign. Once you have them lined up like this, then you can go over to your graphing calculator, and you're going to solve this using a matrix in your calculator. Okay, so let's see if I can get both of these in here at the same time. Clear out whatever you got going on in the home screen. Here's what you're going to do. You're going to go to second, and then underneath the math button right there, you're going to hit this x to the negative 1 button. That's going to take you to the matrix menu. Now you're going to have to put in all of your numbers here. So you're going to go over to edit. All right, so go over to edit, and then you can choose any matrix. I'm just going to choose the first one here. If you've used a matrix before, you may see something off to the side here, but that's fine. You can edit it. All right, so right now it's got a 1 by 1 matrix in there. I'm going to need to do, it goes the number of rows and then the number of columns. So there's 1, 2, 3 rows. So put in 3, enter, and then 4 is the number of columns. So we have 1 column, 2 columns, 3 columns, 4 columns. All right, so 4 goes in the second, and I'm just hitting 4 and then enter. Then it's going to take me down here to my matrix. A matrix is just where you have just little, it's like sort of like a big box, and you have a bunch of little slots for your numbers to go in. So you're going to put in the coefficients here. So you're going to do 5 and then 3, and then the coefficient here is 1, and then negative 30. All right, so 5, enter, 3, enter, 1, enter, negative 30. Make sure you do the negative and not the minus. All right, then my next row, if you're following along right now, pause it and try to see if you can get the coefficients for the next one. All right, so the coefficients for the next row would be 1, negative 3, 2, and 12. All right, so 1, enter, negative 3, enter, 2, enter, 12, enter. And then the last row, 14, negative 2, 3, and negative 52. All right, so 14, negative 2, 3, negative 52. Enter. Now my matrix is in there. Now I need to perform what's called row reduction. You don't need to know how to do this. All you need to know is how to put it in the calculator. So the first thing you're going to do is you want to get back to the home screen. So go second, quit. Make sure everything is cleared out of your home screen, which mine is. All right, then you're going to go back to the matrix menu. So second, and then x to the negative 1. That's going to take me to the matrix menu. All right, then you're going to go over to math. Then scroll down till you see it says RREF. All right, it's option B right there, RREF. That means reduced row echelon form. All right, so we're going to do RREF. Okay, and then you got to tell it which matrix you want to use. So we're going to go back to the matrix menu, second, x to the negative 1. And I want to use the matrix A. That's the one I typed all that information into. And close your little parentheses. And then enter. In the first 3 columns, you should have a 1 here, a 1 here, and then a 1 here on the diagonal. The last column is your answers. All right, so here's our answers. X is negative 5, Y is negative 3, and Z is 4. It's that easy. I would definitely suggest using this method on the test for solving a system of equations with 3 equations and 3 variables.